Got a bridge inspection. You gotta respect other people and not get them in the shot there. And we don't want to wind up a part of it. A victim of that. I'm going to narrate this for you guys pretty much later on. I can't make a live statement like that. That's your post-tensioning you're looking at. The tubes. Ductwork. This guy needs to get more line, I think. There we go. Okay, back to the post-tensioning. These are post-tensioning tubes. They go from one section to the next. Sorry, I can't let you guys listen too much to what they're saying in the background. I already know what they're saying. Yep, so again, these are the post-tension tubes. It's a meeting. Right. Oh, that's a hazard waiting to happen. I'm clearing out of that. I'll show you guys the base. This is where those structures are going to ultimately end up, however you guys want to look at it. That's form liner concrete, caps, more reinforcement. I had a bunch of stills I might put together for you in the image. I said I'd share it at the end of the month if you guys remember. Over here, that's radius. This is epoxy. You guys asked about epoxy. Well, that's what the engineer chose for this one, for the corrosive ability. And those are equivalent to, if you see them, 1, 2, you see how they line up? As you see water standing on them, what does that indicate? You guys figure that out on your own. They line up with these structures here. 1, 2, 3, 4, 5. 1, 2, sorry, 3, 4, 5. Gangplank, crosswalk. Huh. We're gonna leave that alone. No comment. This is protected from erosion. There's your existing pier. Of course, you know, guys, know I'm joking. I can't read your comments if you're saying anything, and I don't even know if I got comments in that activated. But this crosses the river, one of the rivers. Can't tell you yet. I'm going to slip in here and let you guys listen. Yeah, there you go. You can see. Again, nice post-tension cables. Ducts, rather. Cables will go through there, pulling it through. Epoxy. Now, he's over water, right? So you would think he'd have to have a life vest on, right? Right. So look at the vest going over. That is a life vest. Oh, sorry guys. I'll zoom in for you. See it? There we go. And I like staying clear of stuff like that at this point. If that stuff ever breaks, it explodes outward. Anything in that basket. And unless you've seen one break, you know it's staying clear. I've got to touch base with my man that's further in that little crowd of engineers there, so I've got to terminate the video for a minute, and I'll jump back in it live and as soon as I can. I'll show you guys a cofferdam. That's designed to retain the debris on this side and going out. I'll show you the other side. Yeah, can't do it. Gotta wait. It'd be disrespectful to the presenter. In other words, you don't walk away from the person talking. So again, you've got the, that's a form liner that made that design down there. So it's regular 4,500 PSI concrete. I'll share that with you. Waterproofing. The details at the bottom of that, they had to go down extra deep. I'm going to leave out the footage because that might bite me later on, as you guys can imagine. This is infrastructure these days, guys. The crews are, you know, what they need to do to get to the next step. And as you need more people in the next step, you add more. So again, light vest. Scan to the right, light vest. And there's our beautiful post-tensioning again, as you guys might just see the different people coming in or signing in. Alright, I'll get back to you on the video. Hold on, let me see what these guys counted in. I'm actually listening to the meeting at the same time as I got the camera pointed away, so every now and then I turn back to say something to you guys. Here we go, girders. Yeah, so I can share that with you. 480 feet. 480 feet is the span on this one. Let me see, I'll put you in, hold on. Oh, I'm listening to this meeting still, guys. Sorry about that. Okay, different people signing in. So again, that's post-tensioning. Those are the tubes. That's our infamous post-tension that everybody wonders about. See the shape of the bottom of the detail? See how it goes down and back up? Where the forces are created? That's not just extra down the bottom there. That's not decorative. Alright, bear with me while I put the phone down. Listen, let you guys listen. I'll put it lower. I'll let you guys, I'm going to fire up the post-tension question for you guys. Hold on.
We don't want to rush ourselves.
It's getting jumped.
Two girders for day one, 3 girders for day 2. And we did that. We got a late start on Tuesday. We started setting around noon, and it took us about 2 hours per girder on Tuesday. So we wrapped up around 4:30. Yesterday we set 3 girders. As we started around 10:30, 11, and we were done by like 4:30. So we're getting about an hour and a half, 2 hours. And that's from rigging on the barge. So what happens is we truck each girder in. The girder comes one per truck. We pick it up. We have to mount a sole plate underneath of it for the bearing system. Then we fly it out there and we set it on the barge. We stack them all up, all 5 girders up. Then we mount all our temporary supports, like we hang all the strong backs and the whalers and the threaded rods that hang off of it. So the pure girders are pretty straightforward. We only got one set of channel going across the top and the Dewey deck bars hanging down. Then when we get the end girders coming in, the drop-in girders, we have a pretty significant set of strong backs that get mounted on with a bunch of threaded rod, locking and dunnage. So that's going to take more time to get prepped, but we get it all prepped, and then we fly them up and we set them, and then we cinch them down. So the actual picking from the girder, or picking from the barge, setting and restraining the girder, it takes an hour and a half to 2 hours. We will probably improve on that as we get going, but the first set we were kind of cautious, so that's what we ended up doing.
What's the profile of your post-tension?
Profile?
Yeah. You know what? Yeah.
It's kind of up and down and up and down.
Down the bottom. Yeah,
down.
gotcha. Yeah.
Yeah.
Gotcha.
Yeah. And there's 3 ducts.
Yep.
There's 3 ducts in this
Yeah.
one. So we did a similar bridge like this down at Ocean City, New Jersey. So we had a lot of engineering experience and materials on hand. The guy setting these girders, the same guy that set the girders down there. So
that system's already been proven.
Yes. Yeah. So a couple new guys on the crew, so we got a little learning curve there, but the brain trust is the same. So
beautiful, beautiful.
So the job itself is pretty unique. Matt mentioned it. There's a lot of firsts, a lot of detail. It starts with the architectural treatment, as everything's got the form liner on. It's going to be stained. There's a significant decorative lighting package. There's got LED linear lights that are going to be hung on the drip edge underneath the overhangs. There's going to be upwash lighting on the piers, decorative light poles going across. The grand staircase with this curved rebar structure coming out. I like to call it the grand staircase. So we have a smaller one that's going to be not as fancy.
Right.
It's actually got LED lights and the hand railing, and significant handrails and ornamental railings along the parapets. So it's a very architecturally driven job, and a lot of detail, attention to detail. Down to the structural side of it, the technical side with the girders, the girder post-tensioning system, it's the girder erections, down to the soil improvements with the styrofoam embankment on this side, and then when we get on the other side, the ground improvements we did over there. So it's a pretty awesome high-profile project, I think.
Can you say why they chose epoxy? Because it's not salt water, right? Brackish,
I'm
right?
sorry?
It's brackish water.
It's brackish, yeah.
Why did they choose the epoxy? Why the epoxy coated?
Rebar?
Yeah.
I think that's the Delta standard. Everything's epoxy coated, so. It's funny, you go down to North Carolina, and they're doing bridge decks plain bar. Everything's plain, and they're right on the salt marshes. But everything Delaware is epoxy coated. So.
You said ground improvement methods. So you said that with the abutments, you put the styrofoam abutments, but what other methods?
So there's three, I guess, RK&K designed three things or four things really to handle the poor soils around here. On the west approach is styrofoam blocks to mitigate the weight of the approach. Inside this abutment, wing wall underpass structure, and the staircase, and then behind that abutment over there is a lightweight concrete that's going to be placed there to backfill that structure. And then from the wing walls, a couple hundred feet to the east, it was supposed to be the job was advertised with a deep soil mixing method where you would auger flight in basically, I guess, cement to a prescribed depth to stiffen that soil and improve that soil. We used, I guess, a bit time advantage, as you would say, with our experience with Menard. Menard is a company that, they're not the only ones that do it, but they're probably the recognized leader that does this stuff. And they use a grout column system. It's a CMC, or a controlled modulus column. They take the soil profile and analyze it, and the loads that are coming up on it, and they take prescribed allowable settlement rate that you're allowed, and they design these grout, basically they're grout columns, and based on the allowed settlement, the soil condition, they could be a 12-inch or an 18-inch grout column, and spacing changes, and they can fine-tune the spacing from an open, like almost 5 foot by 5 foot, down to a 3.5 by 3.5. And they go in and they got basically a bower rig. It's a track-mounted drill rig. Kind of look like an excavator body with a big drill rig on the front of it. And they have a reverse flight and auger that when it goes into the soil, it doesn't generate any spoils. It pushes the soil down and out. And on the way down, so it's densifying the poor soils on the way down. And they have a sophisticated software package on the machine that measures the torque ratio, the torque reading on that auger. And when it gets a prescribed torque reading that the design called for, they know they hit that stiff layer, then they inject grout through the tip of that auger and pull the auger out and basically tremi-pour a grout column back up to the elevation of your bottom of your load transfer platform. And they worked their way through doing that, generating very little spoils, which on this site was a benefit because everything's contaminated, especially on that side. So by eliminating the amount of spoils we're generating by doing the ground improvement, we reduced the cost to the department to dispose of those spoils. Plus, it's very quick. They're in and out. They did all that over there in about two to 3 weeks, tops. And they worked their way out, and then on top of the columns, you install a load transfer platform, which, depending on the approach, the weight you're trying to carry, and the allowed settlement, it's typically just layers of a GABC and geotextile. And geotextile is not necessarily needed at all spots. So the first 75 feet from our abutment out, we use geotextile because they had to really limit the settlement going into that bridge. You didn't want a lot of settlement going into that bridge. You're trying to keep it at like a ½ inch over a long-term duration. So you use layers of geotextile. It was also to try to, when we redesigned the foundation, we had to work that with the foundation redesign because our foundation designer, H&H, didn't want any load from the soil improvements to be applied to the piles. They didn't want any lateral loading, and that was a huge concern with RK&K in the department. You had this thing called lateral squeeze. So the soil's so poor over there, they're afraid any weight's going to push that out into the river. And they wanted to make sure that this soil improvements that wasn't going to apply any lateral loading to the pile and no down drag. And when you get two engineers from two different companies with with different liabilities, you couldn't get neither one to say, yes, we can allow some, and no, we're not going to provide any. The best we could get out of Menard is we don't anticipate any, and the best we could get out of H&H is
It's possible.
It was possible. So what we ended up doing was the abutment really only needed a 24 by 24 inch square pile. We upsized that to a 30 by 30, just in case there might have been any sort of lateral effect or down drag, which Menard's engineer said most likely not going to happen, but, you know. So the first 75 feet we had geotextile in there to help also with that, and then the last 100 or so feet it's just a 3-foot GABC load transfer pipe.
Oh, okay.
And then you build your embankment on top of that. The MSC walls are sitting on that. They do a lot of it in Jersey, in Pennsylvania, starting it. It just came off a job where PennDOT did a trial study. They did a couple 100 feet with lightweight fill, lightweight concrete, and a couple 100 feet with the Menard. Well, they actually had a H-pile supported embankment and allowed an alternate at bid time. So we bid it with the Menard system, and PennDOT was extremely pleased with how the Menard system. That's again, it was a environmentally contaminated site, heavy lead, and PennDOT had it pre-characterized that the lightweight fill area, which was about 20 to 30,000 yards of excavation, was clean. We get in there, we start digging, we find signs of contamination, we have it tested. That 20 to 30,000 yards of clean material turned to lead impacted that the DOT never had to dispose of. Plus groundwater, contaminated groundwater that we had to dewater the site until we get the concrete in. So the price, the price started to steam, just impile one after another, let alone the CMC section. We were in and out in 3 weeks in building our embankment. The lightweight fill, granted we hit it at a bad time. We were going into the winter, so that we had some weather days where you couldn't place the fill, but it took almost 2 months to construct this lightweight fill section. It took us 3 weeks to do the CMC section, so there's some definite benefits there, especially as a DOT and an owner. It's unfortunate for us as it gets more popular, we're going to lose our bid advantage because people are going to start speccing it. But actually, from what I understand, RK&K, you guys looked at it, but Menard wouldn't give you the spec package because it's proprietary, so you're kind of like, you're stuck in a hard place. So it's always a challenge. Yeah. But that's what we used. And then on the far east side, it was a typical surcharge, quarantine period of it was like 6 months, 150 days. And we had piezometers, inclinometers, and settlement plates that RK&K designed for us to put in, that we could monitor settlement and pore pressures and to make sure everything was working right. And
they did the same thing with the piers. They monitored those also. I'm guessing after they put them in, the system expands. They monitored that for a while to see if it was going to settle some.
For the columns, we haven't loaded the columns yet. Once we get it loaded, we'll have the settlement platform sent to monitor for settlement. But we use that to create the work platform over there to build our bridge because it was a slop hole. So we got in very early, put our Menard system in to get the working platform, the load transfer platform, and from there, that's where we set our crane to build the embankment, the bridge abutments. And now that the abutments are done, we're starting MSC wall construction this week. And we'll start coming up with that and coming up with the settlement platform. So once we actually load it, then we'll start monitoring that.
But they're not going to be abandoned, they're going to be incorporated.
I believe so, yeah.
Ha, quiet, church mice.
Questions?
This is your baby, Ray. I can't take any questions, guys, not yet. Maybe later on after I do it, just let you guys listen in. Thanks. I dealt with it once.
And then up like you and I can just pick it up.
I dealt with it in a full project, but it was 2 foot. This is going to be like 8 foot, he said?
They're different.
Yeah. The system I used was 2 foot.
No, you can walk out to the very end if you want.
Awesome. So you guys come out here. Look at the bar system, Ray. You had to put this bar system together. Obviously, you didn't just bring it up.
They on the other side down the steel erector place. They use their box to put it together.
Oh, gotcha. Yeah, steel. Yeah.
It took them about almost 2 weeks, I think, to put the whole system together, bar, crane, and everything.
And that's only, what's that, Ray? 400? How many feet, Ray? 400 and what? 80?
It's like 8 something.
8 something. Yeah.
Yeah.
I thought, yeah, I got you. But the span this way, Ray, is what? 180? I forget now.
Span is
180 and
the back span's 180.
Yeah.
The center one is whatever 180 times 2 might
It's a beautiful little system, isn't it, Ray? It reminds you of something you designed.
Oh, a lot of people were involved.
You're being modest.
The biggest change was
You're being modest.
the foundations.
Yeah, that's right. I wanted to hear more about that. Were you here for the foundation change?
Yeah, I've been here since
Beginning?
Actually, I've been here since since the middle of last night.
Was it a big stopper when that foundation, when they hit that clay or whatever it was? Yeah. Okay. Beautiful. You know the specs on the concrete is at 4,500?
Yes,
43.
yes. Everything you see is Class A.
Gotcha.
The one difference we're using is when they do the closure boards on the beams, it's going to be like 6,500.
Gotcha. To do it.
Which usually the stuff they use for the footers or whatever you want to call it. I call it a footer, but it's,
Yeah.
on the plane they call it all a pier cap. But
Yes.
part they use for the footer, they use like an 80-20 mix because to keep the what's it called down, they put more fly ash because that was one of their thermal control bores.
Right there.
Where they had all the tubes going through it and kept it cool.
Mm-hmm.
That stuff broke in 3 days at like 5,500. Heritage's concrete usually breaks about 1,000 pounds.
I played with Heritage a couple times. I'm not proud of them. Yeah.
Huh?
You're proud of them? I'd say you like the Heritage? I didn't
Yeah,
like
I've never. I've done this about 8 years now, and I've never.
dealt with Heritage.
I know I've dealt with them exclusively, it's just been coincidence that every contract I'm on, that's who they use.
Yeah.
But I mean,
Because they're certified. You know, they're the ones that certified and got all the transportation to bring it out. But it failed at 55, and they're supposed to make what?
no. This was only supposed to be 45. It broke in 3 days. It got 55.
Excessive. So it was excessive. Gotcha. Yes.
But usually their Class A mix will usually break, especially by 28 days, about 1,000 pounds more than it should be.
When did they test it? Did they test it in 3 days, or did they?
Since that was their first thermal control pour.
Right.
We got an extra set of cylinders that broke them in 3 days just to see where it was coming along, and that's what we got. Yeah.
At 3 days, you're at 55.
Yeah.
Awesome. So
Yes,
okay.
I mean, out of doing this, that's the least of my problems is Heritage concrete usually.
Good.
And if something's wrong with it, and it's a big pour like that, they usually have one of their
Tech
quality
guys,
control guy out here, and they will take care of it instantly.
Yeah, I think it's what, Mike or something like that is there. He's Mark. Yeah. Mark's their yard guy, right?
Yeah, I've dealt. My dealings with them has always been pretty positive.
Yeah, they're pretty certified. So you're going to be here with the foam when you're going to help put down that too? Yeah.
Yeah.
They're all excited about it. I'm not too excited.
The area closed in. What's missing? Well, of course the wing walls are missing, but you got to there's a concrete pad goes down there in the opening before they put the lightweight stuff.
Keep it from racking on the base of it. Keep them coming in.
I guess, yeah.
Stability. What is it? Are they going to solid fill it?
Yes. Yeah. That gets filled all the way up with that lightweight stuff that they make.
Yeah.
The stuff. Nick had a sample of it. It almost looks like a porcelain. It almost looks like volcanic rock.
Yeah. I've used it before. Yeah. Actually, Heritage has it. Also, Pioneer, I think, has a ton of it. You know, uses it a lot.
There's the other place they used it. I was on the interchange.
Right.
Over where 7 and 95 is.
Right.
And they used it to fill like MSC walls there.
Beautiful.
But they didn't look like lava rocks. That looked like a movie prop where you'd have a chunk this big but it only weighed like 5 pounds.
Yeah. That's the stuff I played with, but it was 2 foot.
For the walls over there.
Gotcha.
Here you still have the pour that places over Wall Delaware many more times.
Right.
Who do you work for again?
Yeah, let me see something.